All right, what we're going to do now is we're going to balance a redox reaction. Going through the steps, I'm going to go through them kind of quickly because I'm going to assume that you watched the other video. But in this case, we're going to be in a basic solution. A basic solution is a solution that contains water, again because it's an aqueous solution, but it also contains the hydroxide ion, OH-. We will not have H pluses in a basic solution, but the steps to balancing a redox reaction in a basic solution includes going through the steps we use to balance in an acidic solution. We'll just tack a few steps onto the end. So here's the example that I'm going to start with, and then we'll go through the steps to balance it. All right, we're going to assume this is an acidic solution, so these are probably all aqueous, but that part doesn't matter. Step number 1, let's split it into the two half reactions. Usually you're using the elements besides hydrogen and oxygen to be your clues. Do be a little careful because sometimes hydrogens and oxygens are the species being oxidized or reduced. In this case I have phosphoruses and nitrogen, so they guide me very nicely into splitting into the two half reactions. You want to be very careful as you're rewriting these. You want to make sure that you get all your subscripts correct and that you bring down any charges that are present. If you lose these charges, you're never going to get it balanced correctly. Step number 2, once you split it in the half reactions, is to balance everything except oxygens and hydrogens. That would be the phosphoruses, and they're balanced. That would be the nitrogens over here, and they are balanced. Step number 3 is to balance the oxygen with water. That was our step number 3 previously. It's still our step number 3. Let's see, I have 4 oxygens on the left, only 3 on the right. So I need to add 1 water to give me my 4th oxygen on the right. In this case, I have 3 oxygens on the right, 1 on the left. That means I need 2 more waters on the left to give me 2 more oxygens to balance my oxygens. The 4th step is to balance the hydrogen with H+. Now this is not an acidic solution. These H pluses are not going to stay in my reaction because they can't be present in a basic solution. But we still use this step to balance. In this case I have 3 hydrogens on the left. Notice I have 5 on the right. That means I need 2 more H pluses on the left. I'm kind of squeezing it in. You want to be very careful about being sloppy with your balancing work, because if you're sloppy, you're likely to lose something. On the right-hand half reaction as written, to balance my H's, let's see, I have 4 on the left. I don't have any on the right, so I'm going to add 4 H pluses to the right-hand side. The next step, step number 5, is to balance the charge with electrons. So here we go. On the left, I have a +2. On the right, it's neutral. Go to the more positive side and add electrons until you bring the charge down. So 2 electrons make both sides 0. On the right-hand half reaction, the left is a 0. The right is a +4 for my 4 pluses and -1. How about a +3? Go to the more positive side, that would be the right-hand side, and add electrons to bring your charge down. This is an excellent time to double check that you added electrons to opposite sides in your two half reactions. If you didn't add electrons to opposite sides, you've done something wrong. Go back and fix it. The next step is to balance the transfer of electrons. Sometimes it is balanced at this point, but it's not here. I need to multiply the whole left-hand half reaction by 3. I need to multiply the whole right-hand half reaction by 2 in order to balance that transfer of electrons. I'm going to rewrite them down below. Okay, at this point you have to have the same number of electrons on both the right and the left, and they have to cancel. You also want to watch for any H pluses on both sides or waters on both sides. Let's take care of the H pluses. I have 6 H pluses on the left, 8 H pluses on the right, which means 6 of them cancel, so that I'm left with 2 on the right. I have, and now let's look at our waters. We need to cancel some of those. 3 waters on the left, 4 waters other way around. 3 waters on the right, 4 waters on the left, so 3 of my waters cancel, and I'm left with 1 H2O. Let me add these together. and rewrite it neatly. If my task was to balance this in an acidic solution, I'd be done. But if my task is to balance it in a basic solution, I need one more step in order to take care of the fact that I will not have H pluses in a balanced reaction if it's in a basic solution. So let me get some space and then we'll do the last couple of steps. Alright, again, I'm not going to have H pluses because those will not exist in basic solution. I'm going to take advantage of the fact that I can write the reaction H plus OH minus yields H2O. Take a look at this reaction I've got down here at the bottom. You see it's balanced for both oxygens and hydrogens, and it's also balanced for charges. A neutral charge of the +1 and the -1 on the left give me 0, neutral on the right. I'm going to add OH minuses to both sides of my arrow in order to combine with my H pluses. Let me say that another way. I have 2 H pluses on the right that I need to get rid of, so let me add 2 OH minuses on the right so that these two will combine to give me water. But I can't just add them on the right because that will make my reaction not balanced anymore, so let me add them on both sides. So essentially, I am adding the reaction 2OH minus goes to 2OH minus to both sides. On the left, now I'll have a 2OH minus in my reactants. On the right, the 2OH minus and the 2H plus give me 2 waters. So these add together and it's like adding 2 waters on the right. And now you'll notice I have a water on the left, 2 waters on the right. That reduces down to only 1 water on the right. So let me rewrite it now in its final form. And this is my balanced reaction. It's a redox reaction, and I've balanced it in basic solution.